Ray diagrams. Objective: to see the different rules for constructing a ray diagram for image formation in mirrors and lenses. We know that when light is incident on a curved mirror, it gets reflected and either converges or diverges depending on whether the mirror is concave or convex. Due to this reflection, we can see the image of an object placed in front of these mirrors. Every small point on the object acts as a point source of light, emitting infinite number of light rays. Out of these, if we consider only 2 rays in the direction of the mirror, we can construct a ray diagram, which would help us to understand the nature, position, and relative size of the image. There are certain basic rules which have to be considered while constructing a ray diagram. Let us have a look at these rules. 1. A light ray which is parallel to the principal axis, after reflection from a concave mirror, passes through the principal focus. In the case of a convex mirror, the ray after reflection appears to diverge from the principal focus. 2. A ray of light which passes through the principal focus of a concave mirror gets reflected by it and emerges parallel to the principal axis. Similarly, in the case of a convex mirror, the ray of light directed towards the principal focus after reflection will emerge parallel to the principal axis. 3. A ray of light passing through the center of curvature of a concave mirror after reflection will not undergo any change in path. Rather, it retraces its own path. Similarly, in the case of a convex mirror, the ray of light directed towards its center of curvature after reflection is reflected back along the same path. 4. A ray of light which is incident at the pole P of the concave mirror, making an angle with its principal axis, gets reflected by the same angle in accordance with the laws of reflection. Similar is the case with a convex mirror also. Using these 4 rules for constructing the ray diagram, we can understand how images are formed in mirrors. Similar rules are applicable for construction of the ray diagrams in lenses. Let us have a look at the 3 rules used for ray diagram of image formation in lenses. 1. A light ray, which is parallel to the principal axis, after refraction from the convex lens, passes through the principal focus on the other side of the lens. In the case of a concave lens, the ray appears to diverge from the principal focus on the same side of the lens. 2. A ray of light which passes through the principal focus gets refracted by the convex lens and emerges parallel to the principal axis. Similarly, in the case of a concave lens, the ray of light appearing to meet at the principal focus will emerge parallel to the principal axis. 3. A ray of light passing through the optical center of a lens will not undergo any deviation, rather it emerges straight along its path. Thus, using these 3 rules for construction of the ray diagram, we can understand how images are formed in lenses. We will also study the working of various optical instruments later using the ray diagrams.